All right, so if you're watching this, this is your first lesson while I'm out on leave with my little baby at home. I'm going to do my best impersonation these next 2 to 3 weeks of Ron Clark. If you remember this scene here.
Okay, now just because I'm on this videotape doesn't mean that I can't see you. Alita, is that gum? All right, is everybody ready? Yes, sir. Gravity, the force of attraction between two objects.
All right, so basically I want to be left some videos for the sub, and I want to be kind of giving you the video reference for each of the lessons you're going to be doing while I'm out. So the different topics that you're going to be learning while I'm gone basically are right here. So we're going to start with linear versus nonlinear, function or not a function, and then scientific notation is the bigger unit where you're going to be doing converting between standard and scientific notation. You'll learn how to multiply and divide numbers in scientific notation, which takes a few days, and then you'll end with word problems. Remember, whatever you learn these 2 or 3 weeks, you will be getting homework. You'll also definitely be having some assessments when I do get back. So while I'm out, obviously, I know it's not going to be perfect, but I expect that you come in every day and behave to your best ability. And of course, try your best with all the math. Of course, if this is D or E period, you have Mrs. Lassard, and in E period, you have Mrs. Carvalho as well to help you out. So let's get started with our first lesson, which is linear versus nonlinear. So back in second quarter, we talked a lot about linear relationships, and basically we did graphs, equations, and tables. So basically really simple but yet common topic for 8th grade and on the MCAS is whether or not something is either a linear function, and then there's everything else, which is like nonlinear functions. So the easiest is the graph to decide. To be a linear relationship, if it's a graph, it really just has to be a straight line. Except for, of course, this line right here. That is a line that's called what? Yeah, that's undefined. So remember, as you're watching these videos, you should definitely be copying down what I do in the video. So that's not linear, it's undefined. Anything that's straight line is linear. And then, of course, zero slopes, those are considered linear as well. But again, undefined is not linear. Okay, so that's an easy test for graphs. Again, it has to be a straight line. If it's not linear, it's not a straight line. Anything that's not curved, that has some type of curve to it, or has breaks in the graphs, that's non-linear. All right, hopefully you watched the Jimmy Chang, I think that's his name, the video on YouTube for his lesson, because he puts it best. When it comes to equations, pretty much all equations are linear, except the equation cannot have x raised to a power, or x in the denominator, or the other one that I didn't write here, you might want to copy this down, is you cannot have square root of x. So basically, let's write in this side all the linear equations, just examples. So you could have, 3x plus 5 equals 2. Equals 2, so that's definitely linear. You could have y equals negative 2x minus 5. You could have just y equals negative 2x. You could have x divided by 3 plus 2 equals y, because again, the x is in the numerator, not the denominator. Yeah, so those are all linear functions. So here's an easy way to spot out equations that are not linear. Basically, equations that are not linear will have the x raised to an exponent or an x in the denominator, or every once in a while you would see like the square root of x. So if you go here, let's write down some that are not linear. So you could have like y equals 2x to the second power. That little squared makes it not linear. Plus 5, you could have square root of x plus 1 equals -5. That's not linear. You could have 7 over x plus 2 equals y. That's not linear because of this. You can't have it raised to a negative exponent either because that actually drops it down. We'll learn at a different lesson. So say you had 5x to the -3rd equals y. That's not linear. Yeah, and even if you had 5x to the +2 equals y, anything like that, those are all the examples of nonlinear functions. So again, just keep that in mind. If I was to go on Desmos and graph any of these, the lines would definitely not be straight. So then the last one and the hardest one to check is your table. So in order to be linear, it really just has to have a constant rate of change, or in other words, a slope, and it's always the same slope and never changes. It's the hardest one to check because you may have to check all the coordinates with the slope formula, or the best way in the foolproof way is really to sketch a graph and see if you get a straight line. So basically what I want to do is turn over the back, and we're going to do a couple of examples of a table that's linear and a couple tables that are not linear, or at least one table that's not linear. So let's copy this down here. So here's an example of a linear function. So you have your x's and your y's. Let's do -2, 15, 0, 12, 2, 9, 4, 6, 6, 3. So make sure you're copying this down. All right, so if you look here, it's easy to tell that these are going up by 2 every time. And can someone tell me these are going actually down by 3? So because it's a constant rate for every single one, you can definitely say it's linear. If I check the slope and I pick these 2 points and these 2 points, I would do like 6 minus 9, and x2 minus x1 would be 4 minus 2. So this would be 3 over 2. So the slope's, let's see here, -3 over 2. It's a -3 over 2. If I checked any other combination of coordinates, I would always get this slope. Another example here that you might want to check the coordinates for graph is, say you have x and y. You go -8, 3, 0, 1, 4, 0, 8, -1. Okay, so when you're looking at these, right, you can see here it's going up by 8, up by 4, and then up by 4 again. So it's a little bit uneven, but over here it's going down 2, down 1, down another 1. So to check that, you might want to look at the slopes to see if they're the same, because it might trick you. So let's say I look at, I'll just start with these 2 coordinates. If I did the slope here, we would do 1 minus 3 and 0 minus -8. So that would be -2 over 8, or -1/4. So that would be the slope there. Now let's say I chose the next 2 coordinates here and here. So that would be 0 minus 1, 4 minus 0. That's still -1/4, so the slope's the same. Say I chose, I'll do it here in purple, these 2 coordinates. This would be -1 minus 0, and 8 minus 4. It's still -1/4. So no matter what 2 coordinates I choose, as long as the slope's -1/4, then it's consistent and it's linear. Usually on MCAS, you would see more examples like this and less like this, but if there are, sometimes you have to check every single combination of slopes to make sure they are the same and constant, or graph them. All right, and here's the last example of a nonlinear. These are easy to make. So you have x, y. We'll do -2, 8, 0, 4, 2, 1, and then 4, -4. So at first you kind of look here and like, oh look, it's going up by 2, must be linear. Then over here, there's a problem. It goes down -4, down 3, and then down 5. So you're thinking to yourself, all right, maybe something doesn't look right. It's not linear. Let me check a couple slopes. So I'll do these two coordinates in purple. 1 minus 4, 2 minus 0. Again, this comes from the the y 2 minus y1, x2 minus x1 formula that I'm getting this from. So this comes out to -3/2. And then let's say I try these two coordinates in red. You're left with -4 minus 1, 4 minus 2. This is -5/2. So these slopes here, if I kind of like draw a line between the two here, they're definitely not equal to each other. So this would be a nonlinear example. So I hope this helps. You're about to try some classwork and go ahead and decide if things are linear or nonlinear. Yeah, the tables are the hardest because you either have to graph them to see if they're straight or check all their slopes. But in general, just remember it has to be a straight line. Remember the video with Jimmy Chang that if you see any of this junk like x in the square root, if you see, oh yeah, I think I even forgot to write it. Like if you had like 2 to the x power equals 3, or y, excuse me, that's not linear. So you can't have x in the exponent. You can't have x raised to a power. Any of this stuff, x in the denominator, that's all examples of nonlinear, because if you graphed it, it would not give you a straight line. So I hope this helps you start lesson 1. You'll have some classwork and some homework to do, and I believe tomorrow or next time you will hopefully see a math message relating to this.